Hello, and welcome to the lesson on section 11.3, Graphing in Polar Coordinates. In this lesson, we'll review how to graph points and equations in polar coordinates, and how to convert equations between rectangular and polar form. In my first example, I'll review how to sketch a polar graph without a calculator. In this case, the graph of r equals the sine of theta. Using the fact that the square root of 2 is approximately equal to 0.7, and the square root of 3 over 2 is approximately equal to 0.9, I'll fill in the table with the values of r at these values of theta. In polar form, the first coordinate is r and the second coordinate is theta. So keep in mind that if we were given coordinates as ordered pairs, the order of the coordinates as they're presented in this table would be backwards. Now I'll start plotting points, starting at theta equals 0. Each ring in this graph represents 1/10. At the spoke representing pi over 6, I'll graph a point on the fifth ring to represent a radius of 1/2. Pi over 4 is between the pi over 6 and pi over 3 spokes. Here's the point at theta equals pi over 3, and so on. When I get to 7 pi over 6 in the table, a negative radius means to go backwards through the origin. This point would end up in the same place as 0.5 pi over 6. And the remaining points in the table would also overlap with points that I've already graphed. In my second example, I'll graph r equals 1 minus 2 sine theta. As you get more accustomed to working in polar coordinates, you'll be able to skip over some values in this table. For example, in many cases, you may be able to find only the values of theta that result in maximum, minimum, and 0 values for r. In this example, I'll stick to values of theta for which sine is easy to calculate. I know that the sine is 0 at 0, pi, and 2 pi. So that makes r equal 1 at those angles. Sine is 1/2 at pi over 6 and 5 pi over 6, causing r to be 0. And sine is negative 1/2 at 7 pi over 6 and 11 pi over 6, causing r to be 2. At pi over 2, sine is 1, making r equal negative 1. And at 3 pi over 2, sine is negative 1, making r 3. Then I'll plot these points, 1 or 2 at a time, connecting along the way. Here's a review of some formulas relating polar and rectangular coordinates. All of these formulas are based off of the right triangle you see in the diagram. If you know this triangle, you should be able to find all of these formulas easily. Using right triangle trig, you can see that the cosine of theta is equal to the adjacent side x over the hypotenuse r, and likewise, the sine of theta equals y over r, and tan theta equals y over x. Solving the first two for x and y results in x equals r cosine theta and y equals r sine theta. Also, by the Pythagorean theorem, x squared plus y squared equals r squared. In example 3, let's convert the polar equation r equals 2 secant theta to rectangular or Cartesian form. This means that I need to convert the r's and thetas to x's and or y's. I'll rewrite 2 secant theta as 2 over cosine theta. Then cross multiplying gives me r cosine theta equals 2. And x can replace r cosine theta. In example 4, let's convert the polar equation r equals 2 times 1 plus cosine theta to rectangular. I'd like that cosine theta to be an r cosine theta, so I can replace it with an x. So I'll multiply both sides by r to make this happen. Now I can replace r squared with x squared plus y squared, replace r with the square root of x squared plus y squared, and replace r cosine theta with x. This concludes the lesson on section 11.3, Graphing in Polar Coordinates.